Welcome back to my channel. In this video, we will explore more intertidal organisms and their adaptations. This is important for you to understand the community pattern. Organisms that live in the splash zone and the high tide zones are the major focus of this video. Firstly, we investigate the adaptations of whelks. Whelks, a type of marine snail, are well adapted to the rocky shore environment. Here, they face challenges such as strong waves, desiccation, predation, and competition. Their coiled shell provides protection for their soft bodies against predators and mechanical damage from wave action. The thick, sturdy shell offers additional protection from predators and reduces the risk of desiccation. Whelks have a tough, trapdoor-like structure, also called an operculum, that seals the shell opening. This prevents water loss and protects against desiccation during low tide. Whelks possess a rasping tongue-like structure called radula with tiny teeth, which they use to bore holes into the shells of prey like mussels, barnacles, and other mollusks. Some whelks can secrete acids to help weaken the shells of their prey, making it easier to feed. Their specialized diet allows them to exploit a food source that many other rocky shore inhabitants cannot. Whelks use their strong, muscular foot to grip rocky surfaces securely, preventing them from being dislodged by waves. They produce mucus that helps them cling to slippery surfaces and reduces water loss. By withdrawing into their shell and closing the operculum, whelks can retain moisture during exposure to air at low tide. Whelks are adapted to withstand the varying salinity levels found in tide pools and splash zones. They produce large numbers of eggs, which increases the chances of offspring survival in the unpredictable intertidal environment. Many whelks are more active at night, reducing exposure to predators and the sun, which helps prevent desiccation. Whelks time their activities, such as feeding, with the tides to take advantage of water coverage and prey availability. Their ability to seal their operculum and slow down their metabolism allows them to survive extended exposure to air during low tide. The shell provides insulation against temperature fluctuations common on rocky shores. The coloration and pattern of their shells often blend with the rocky environment, making them less visible to predators. When threatened, whelks retreat into their shell, protecting their vulnerable body parts. These adaptations enable whelks to thrive in the challenging intertidal zone, making them efficient predators and survivors on the rocky shore. The next one on the list is chitons. Chitons are marine mollusks commonly found in the intertidal zones of New Zealand's rocky shores. They have evolved remarkable adaptations to thrive in this challenging environment. Chitons have 8 articulated shell plates, allowing flexibility to conform to the irregular surfaces of rocks. This design offers protection from predators and wave impact while maintaining a tight grip on substrates. Chitons possess a specialized radula with rows of teeth hardened with magnetite, enabling them to scrape algae and biofilm from rock surfaces efficiently. To avoid desiccation and predation, chitons are primarily active at night, feeding when conditions are cooler and safer. Chitons limit their movement to conserve energy and reduce exposure to predators during low tides. Their ability to clamp tightly onto rocks reduces water loss during low tide, helping them survive prolonged periods of air exposure. Chitons can endure significant changes in temperature and salinity due to their slow metabolic rates and physiological resilience. Their gills are adapted to function in both water and the moist air of the intertidal zone, ensuring effective respiration. These adaptations allow chitons to play a vital role in the ecosystem by grazing on algae. It helps prevent algal overgrowth and serves as prey for higher trophic level organisms like birds and fish. Another common intertidal organism is the black mussel. Black mussels, commonly found in the intertidal zones of New Zealand's rocky shores, exhibit remarkable adaptations. These adaptations enable them to survive their habitat's dynamic and harsh conditions. Mussels have a tough, calcified shell that protects against predation, wave impact, and desiccation. The black coloration of the shell helps absorb heat, which can be beneficial in cooler environments. Black mussels produce strong, silky byssal threads that anchor them to rocks, preventing dislodging by powerful waves or currents. Their streamlined and tightly packed form reduces drag from water movement and minimizes the risk of being swept away. Mussels often live in dense groups, which reduces water loss during low tide by creating a humid microenvironment. Clustering also offers collective protection against predators. Mussels orient themselves to minimize exposure to direct sunlight and drying vents, helping them retain moisture during low tides. Once attached, mussels rarely move, conserving energy and maintaining a secure position on the substrate. During low tide, mussels close their shells tightly to retain water and prevent desiccation. This also protects their soft tissues from environmental stressors like high salinity and temperature fluctuations. Black mussels can withstand wide variations in temperature and salinity. This is due to their ability to regulate metabolic processes and maintain homeostasis. During high tide, mussels open their shells to filter plankton and nutrients from the water. Their gills are adapted for efficient gas exchange and food capture in varying water conditions. Black mussels contribute significantly to the intertidal ecosystem by filtering water, which enhances water clarity. It provides habitat and protection for smaller organisms, including barnacles and crabs. They are also crucial food sources for predators like seabirds, fish, and starfish. These adaptations make black mussels resilient and integral to the rocky shore ecosystem. The last organism that we are going to investigate in this session is the rock oyster. Rock oysters found in the intertidal zones of New Zealand's North Island have developed a range of adaptations that enable them to thrive in this challenging environment. Their thick, calcified shells protect them from predators, wave action, and desiccation during low tide. The shells are irregularly shaped, allowing them to fit snugly against the substrate or other oysters, reducing water loss and damage from waves. Rock oysters secrete a powerful adhesive substance that cements them permanently to rocks or other hard surfaces, preventing dislodgement by waves or currents. Rock oysters often form dense clusters, creating a communal habitat that traps moisture and reduces individual water loss during low tide. They open their shells only during high tide for feeding and respiration, minimizing exposure to air and reducing the risk of drying out. During low tide, rock oysters close their shells tightly to conserve water, maintain internal moisture, and protect themselves from predators. Their gills are adapted to filter plankton and organic particles from water, even in turbid conditions, ensuring a steady food supply during high tide. Rock oysters can survive extreme fluctuations in temperature, salinity, and oxygen levels typical of intertidal zones. Their clustered shells create microhabitats for smaller marine organisms like barnacles, crabs, and algae. They serve as a vital food source for birds, fish, and other predators. By filtering large volumes of water, they improve water quality and nutrient cycling. These adaptations ensure rock oysters' survival and ecological success in the intertidal zones, where they withstand constant exposure to both aquatic and terrestrial conditions. Thanks for watching this video on intertidal organisms and their adaptations to survive in that habitat. We look at more organisms on the rocky shore in my next video.